This video is on solving literal equations. Literal equations are equations with lots of letters. The letters are variables which stand for different quantities. The most common kind of literal equation that you see in mathematics is a literal equation that is a formula for calculating something. For example, distance d equals rate times time. So d equals RT. The perimeter of a rectangle is 2 times the length plus 2 times the width. So P equals 2L plus 2W. That's a formula. The third one I have here is the area of a circle, which is given by pi times r squared. Notice each of these formulas has more than one letter in it. Letter, hence the word literal equations. When we solve literal equations, we're solving for a specified variable, so someone has to tell us which variable we're trying to isolate. We will not get x equal number answers, but rather we will get a rearrangement of the letters in the original formula. So you're still going to have all the same letters, probably most of the same numbers unless there's some reducing, but the letters are going to be in different places. Okay, there is one rule when working with equations, and that is to do the same thing to both sides. So you're going to have a goal in mind, and you're going to do the same thing to both sides until you've reached your goal. Our first example is distance equals rate times time. Solve for r. So we're isolating the rate in the formula. Rate is another word for speed. Well, draw a line at the equals. The variable we're solving for is r. So we need to move any letter on the same side of the equation with r to the other side, but we need to do it in a legitimate way. R is understood to be multiplied by t. So we want the t to cancel and reduce to 1. T divided by t is 1. So dividing by t isolates the r, and we get r equals distance, d divided by time, t. So the solution is rate equals distance divided by time. Notice we still have all the same letters as the original formula. They're just in slightly different places. Next example. This formula relates Fahrenheit temperature to Celsius temperature. Fahrenheit equals 9/5 times Celsius plus 32. And we're going to solve this for C. So currently the formula will take as input a Celsius measured temperature and turn it into a Fahrenheit measured temperature. So let me just write Celsius so you can see the word. And this is Fahrenheit. I hope I spelled that right. And we're going to solve it for C. So we're going to isolate C. Now I'm going to recopy my equation since I wrote on it. And then I'm going to separate my two sides of my equation by drawing a line at the equals. I'm trying to isolate the C because I was told to solve for C. I need to zero out the plus 32. Since 32 minus 32 is 0, that's what I do to both sides. Now, because f is not a number, I can't actually do any subtraction on the left. All I can do is write f minus 32 equals 9/5 C, and then 32 minus 32 is 0. Now I need to get C, remember, by itself. C is currently being multiplied by 9/5. So I'm going to divide by 9/5 because when you divide a number by itself, it reduces to 1. So dividing by 9/5 is what I need to do. Now this left side might look really awful to you, so just hang tight. I get f minus 32 all over 9/5 equals capital C. I'm technically finished, except that left side is not simplified, and that's not okay. Now, I don't know if you remember this or not. Let's see. In elementary school, some teachers call it keep, change, flip, KCF. And that means keep the numerator, change the divide to times, and flip the fraction over. So I keep the numerator, I change the division bar to a multiplication, and I flip the denominator 9/5 and make it 5/9. And this is actually the formula. This is the answer. I'm going to put the 9/5 in front because that's just sort of traditional. But this is the formula for finding Celsius when you're given Fahrenheit. Next example. We have an equation, x equals 2y minus 6, and we want to solve for y. Well, we're going to draw a line at the equal sign. We're solving for y, so we're trying to get y by itself. I'm going to zero out that 6 by adding 6 to both sides. X plus 6 can't actually be calculated because I don't know the value of x. So I have x plus 6 equals 2y. I'm isolating y, which is being multiplied by 2, so I divide both sides by 2. Because 2 divided by 2 is 1, and I get x plus 6 all over 2 equals y, and I'm finished. Now, some students get a little confused when the answer in the back of the book doesn't look like the answer they got. So I'm going to write this one two more ways. X plus 6 all over 2 can also be written x over 2 plus 6 over 2 equals y, which is x over 2 plus 6 divided by 2 is 3 equals y. So that is another way to write the answer. Or there's one more way. The next way uses the fact that there's a 1 in front of that x. So you can write the x over 2 as 1/2 times x plus 3 equals y. And when we learn about linear functions later on in the course, you're going to see this kind of expression a lot. Next example. I have the area formula for a triangle. Its area equals 1/2 base times height, or 1/2 BH. We're going to solve for base, or B. I'm going to circle the B. Now that B has a 1/2 multiplied in front, and it has an H multiplied around back. I have to move both the 1/2 and the H. Moving the H is really easy. So I'm going to go ahead, since B is multiplied by H, I'm going to go ahead and divide both sides by H. So I have A over H equals 1/2 times B. Now to move the 1/2, we're going to divide by it because it's understood multiplication. 1/2 divided by 1/2 is 1. So if I do it to the right side, I have to do it to the left side. And now I have this crazy looking A over H over 1/2 equals B. Now you cannot absolutely leave your answer like that. Technically it's correct, but it needs to be simplified. We're going to use keep, change, flip again. We're going to keep the numerator, we're going to change the fraction bar, and we're going to flip the fraction in the denominator. So I'm going to have keep a over h, change divide to multiply, flip the 1/2 over, and that's equal to b. So my final answer is 2 times a over 1 times h equals b. And I'm finished with that example. One more example. 2x minus 3y equals 6. I want you to solve it for y. For y. I'm going to go ahead and circle my y. Now notice that y is being multiplied. It has a -3 coefficient that's multiplied by the y. And there's also this 2x term at the front. We're going to zero out the 2x by subtracting it. 2x minus 2x is 0, which leaves the -3y by itself. Now, of course, if I subtract 2x on the left, I have to subtract 2x on the right. 6 minus 2x can't be simplified because they're not like terms. I'm going to put the -2x first and then put plus 6 around back. Now my goal, remember, is to solve for y. Now y is currently being multiplied by -3. I'm going to divide it by -3 because -3 divided by -3 is 1, and that leaves y by itself. Now if I divide the left by -3, I have to divide the right by -3. So I have -2x plus 6 all over -3. This would not be a common way to write this answer because there's a lead negative in the numerator. There's also a negative in the denominator, and both of those things are sort of bad manners in math. So we're going to use some skills we used in the example 2 before this one. And we're going to write that as y equals -2x over -3 plus 6 over -3. So basically I split my numerator apart and gave each term the -3 denominator. Now I have a negative divided by a negative, which is a positive 2/3. And then I have 6 divided by -3, which is -2. And this is absolutely the preferred way to leave that answer. All right, so there's 4 examples of solving, or maybe 5 examples of solving literal equations. All you're doing is rearranging things without breaking any rules. Thank you for watching.